Welcome to Automated Visual Software Analytics. This part is about software development. We will investigate software engineering principles, the software development process, and software development effectiveness. Let's start with software engineering. There are many definitions for software engineering. General, software engineering refers to the study and application of engineering, design, development, and maintenance of software. It's also a key goal of software engineering to provide a systematic, disciplined, even quantifiable approach that leads to the delivery of correct software. Software engineering in practice refers to engineering principles known from other disciplines. As a state-of-the-art technique, it aims at developing quality software within a given time budget and within a given money budget. Software engineering is a complicated process because it typically involves a multi-person construction of a complex software system, and it aims at constructing a complex software system having possibly multiple versions. So it's a team-oriented process, and it's a continuous development that has to be driven, steered, and monitored by software engineering techniques. For software engineering, we can take advantage of different software engineering environments. By software engineering environment, we refer to hardware, software, and even firmware used to perform a software engineering effort. Software engineering environments, and most of you are familiar with some of them, include, for example, integrated development environments that also contain and provide access to compilers, assemblers, interpreters. It includes also operating systems, libraries, or frameworks for software development. It's complemented by several tools such as debuggers, simulators, emulators. Software development also requires test tools, documentation tools, and even source code management system repositories that help to handle this multi-person process of developing a complex software system. Today, in many development projects, we use integrated development environments. There's a picture on the right that somehow bundle different tools and techniques into one single user interface and provide access to the underlying software repositories. But software engineering environments cannot solve the key issues of software engineering, namely a quantifiable, a systematic, a disciplined approach. These tools can help you to do so, but these tools by itself are not ensuring that, do not ensure that your software quality ultimately is reached. The key problem behind software engineering is illustrated in this cartoon. Maybe most of you have seen it, one variant of this cartoon at least. It's about the different stakeholders and what they want, what they see, what they understand when we talk about a complex computer-based system, and in particular about a complex software-based system. It's illustrating a simple problem, a simple goal, and the different views stakeholders in the software engineering process may have. For example, what is the organizational standpoint? What does the integration team think about in an ongoing project? how managers would implement it, how consultants describe it, the documentation point of view, the operations point of view, the commercial aspects and the support, and finally what customers, the organization or clients would really need. So this cartoon basically illustrates that the development of complex software systems is faced by different perspectives of different groups of stakeholders. So as it is a very complex situation, software engineering has no simple answers to these issues. However, we will see how we can at least approach software effectiveness by using analytics. First, let's have a look at the software development process. The software development process reflects the user's needs and translates these needs into features of a software product. Common translation steps include requirement analysis, software design, the implementations, testing procedures and frameworks, as well as deployment activities. For the software development process, we typically apply a methodology. For example, the waterfall models, prototyping, iterative and incremental development, spiral models, rapid application development, extreme programming, Scrum, or agile software development. Yeah, at this point we also can ask, what about the nature of the software development? It's faced by the expressiveness. What does this mean? It's a phenomenon in software development, in contrast to traditional engineering disciplines, that for the same specification you commonly get more than one functionally identical or equivalent implementation. If you would construct, for example, a bridge, you would expect that for a given specification of the bridge, there is exactly one way to realize this project. In contrast, in software engineering, the solution is not as unique as it should be, because software is complex, software is flexible, and software has a great degree of expressiveness. So each variant typically differs with respect to runtime performance, to errors, reliability, robustness, or documentation. Insofar, there is never a unique or canonical solution to most software development implementations. Programming languages and their use have a strong impact, of course, on how solutions are expressed, on how solutions are translated into software code, into implementations. Software development processes, for example, here is a Scrum process, define distinct stages that have to be processed and achieved. They are typically semi-formal definitions of process activities, inputs, outcomes, and rules of involved people. Software development process methodologies state what developers and other stakeholders shall do at a certain point in time, at a certain point during the process of the development. Insofar, software development process methodologies are normative, so they describe what shall be done. Yeah. Apart from the question which software methodology we use in a concrete software project, the question is it effective? And what does effectiveness mean? Effectiveness means the degree to which efforts spent in software development activities lead to actually positive consequences and results, for example, in terms of software quality, software functionality, and software evolution. So effectiveness asks, what is the outcome? It does not ask what shall be done. It asks, do we have the right output? Do we have the right results? It's a key factor during the long-lasting maintenance phase, especially in the case of aging, complex computer-based systems like legacy systems. Effectiveness depends, among other criteria, on how efficient program understanding and comprehension takes place. Program understanding and comprehension is essential for software maintenance. And software maintenance represents a major and dominant phase in the lifetime of a software system. So software effectiveness actually refers to a key problem in software development. How take we advantage of the spent money, of the spent time in a software development activity with respect to the concrete outcomes, with respect to the concrete and positive results? Let's summarize this part. For all complex computer-based systems, a software development process methodology is required, used to set up, model, organize, and steer software development activities. The choice of a methodology depends on the type of system. It depends also on the company's experience, on regulations set up in an organization or company, or even on fashions. So there is not a true and only model that is used today. We have different methodologies that can be used, and as a common characteristic, all these methodologies are not strictly formal, nor can they be applied in perfection. That is, developing software is and remains a human activity. If we take into account, if we consider these characteristics, we can ask, what can software analytics do here? Software analytics is not bound to a specific software development process methodology. It's even a non-normative approach. That is, software analytics analyzes, evaluates, and visualizes the as-is status and helps to identify trends and phenomena regardless of the methodology actually used in a concrete development project. Insofar, software analytics is a complementary approach to methodologies which can be generally applied to all software development projects. So, in summary, software development processes rely on methodologies. There are different methodologies available. Some more dynamic ones include Agile methods or Scrum. Most likely you will use a kind of these methodologies in your projects. Methodologies tend to be normative, so they tell you what you shall do. And it depends on your manager or your own degree of personal organization, whether you fulfill all these steps or not. But at the end, it will be a human activity with all the flaws, all the weaknesses involved here. Software analytics, however, is complementary to methodologies. Software analytics aims at supporting you to gain better insights, to gain program understanding and comprehension during software maintenance. Yeah, this concludes this part about software development, a brief introduction into software engineering aspects, into software development processes, and the question for software development effectiveness. The terminology introduced here include software engineering as the application of a systematic, disciplined, quantifiable approach to the development, operation, and maintenance of software. That is the application of engineering to software. The software development process, also a key term, denotes the process by which user needs are translated into a software product. The process involves translating user needs into software requirements, transforming the software requirements into design, implementing the design in code, testing the code, and sometimes installing and checking out the software for operational use. Yeah, there's another key term we have introduced. It's effectiveness. It denotes the degree to which efforts spent in software development lead to actually wanted results in terms of, for example, corrective, adaptive, preventive, or perfective maintenance. This terminology has been taken from software diagnostics technology. As further reading, I can recommend, for example, this book about the rational unified process. It reflects on the key issues, the key stakeholder groups, and the key conceptual and practical models that can be applied to set up a software methodology. Let me give you some final remarks on this part. First remark, there's no winner in the arena of software development process methodology. Also, many developer teams today tend to use dynamic models such as extreme programming or Scrum. But the methodology does not fully solve the issue of effectiveness for software maintenance. The methodology can help you to achieve effectiveness, but it's not an inherent property of a methodology to achieve effectiveness. To achieve effectiveness, we have to take into consideration many other tools and techniques to speed up the process and to ensure effectiveness. One important point is that all developers should understand how the applied methodology works. If developers, if stakeholders do not understand the theoretical model, then it will be extremely hard to achieve effectiveness. Regardless of the methodology, software analytics is a complementary instrument, to check the real status of a software system, its implementation, its behavior, its evolution, and the as-is situation in order to identify risks, challenges, etc. in advance. So this is about software analytics in the scope of software development process methodologies.